Okay, good evening. We are still in singly reinforced section, USD Method. Last lecture or video, we discussed the bending formula as well as the shear formula, including the stirrups. Tonight, we will discuss the band. When we say band, that is the length of embedment. This one, length of embedment. Length of development is equal to BDL times MF must greater than or equal to 0.30 meter. BDL is basic development length. For the basic development length, number 35 or smaller bar, the basic development length is equal to 0.020 ABFY divided by the square root of F prime C, and must be greater than or equal to 0.060 dBFY. The AB here is the individual cross-sectional area of individual bar. Okay. And dB here is the diameter of the bar. That's for the number 35 or smaller bar. For number 45 bars, BDL, basic development length, is equal to 25 FY divided by the square root of F prime C. This is the formula for BDL for number 45 bars. MF means modification factor. Modification factor is equal to K1, K2, K3, K4. Okay. For top bar, K1 is 1.40. And the bars with Fy greater than 400 megapascal, the K2 is equal to 2.0 minus 400 over Fy. That is for the bars with Fy greater than 400 megapascal. For the slab and footing, for the slab, spacing or the spacing of the steel bar for the slab 120, K1 is equal to 1.0. And for the concrete covering, maybe this is a footing. For concrete covering, greater than or equal to 0.70 meter, the K2 is equal to 1.80 for the concrete covering, greater than or equal to 0.70 meters. For the beam, K3 is equals 1.0. And for the Fy equals to 300 megapascal, the K2 is equal to 1.0. And the axis bar, the K4 is equal to AS required over the AS provide. Meaning, this is, for example, if the required area of the cross-sectional area of the steel bar is this AS divided by the provide cross-sectional area of the bar. For example, the required is only, this is an example only, 1,200 squared for the required. But in the computation, sometimes you use the, for example, 1,300 mm. This is the provide. This is the required, and you use 1,300 millimeter squared. So that is the AS required and the AS provide. AS provide is the area of the individual bar times the number of bar. That is the K4 for the axis bar. And for the beam, with an diff of 0.20, K1 is 1.0. For the bend, 90 degrees bend, the embedment or the development or the embedment length is 12 times BD. BD here is the bar diameter and must be greater than or equal to 0.30. That is the length of embedment. For the bend 180 degrees, the length of embedment is 4 times BD must greater than or equal to 2.5 inches. That is, this BD is bar diameter. So this is for the development band as well as the modification factor. Okay, we have here an example of single reinforced USD method. USD problem. In a problem says a reinforced concrete beam as shown in figure. This is the figure. As shown in figure, carries a total applied ultimate moment of 500 kilonewton meter. 500 kilonewton meter. The requirement is to check the adequacy of the section. This section. To check the adequacy. Meaning the capacity. Or meaning if it is safe to carry the applied ultimate moment of 500 kilonewton meter. So that is what we are going to find out. Check the adequacy of the section. Use F'C 35 megapascal and Fy 400 megapascal. So this is the section. The centroid of the steel bar, tension bar, is 140 millimeter, and the distance of the centroid to the bottom fiber of the beam is 60 millimeter, and the base of the beam is 300 millimeter. So what is required is the ultimate moment capacity of this section. So we will going to find out the moment capacity of the ultimate moment capacity of this section. If the ultimate capacity of this section is less than the 500 kilonewton meter, meaning the section is inadequate, meaning unsafe, failure. But if the ultimate moment capacity of the section is equal to 500 kilonewton meter or greater than, meaning this section is adequate. So this will going to find out in the next video, inshallah. So I will cut the lecture this time, and inshallah we will going to continue this in the next video. Thank you for watching.